All right, this is Honors Algebra 2 Pre-Calculus. We're doing 3.4 in Algebra 2, which is systems of linear equations. So now we're putting together the systems of equations that we've seen where there are multiple equations with the same variable. And we're putting together graphing linear inequalities, which we learned how to do in the last section. And once we put all of that stuff together, we're going to make it so that we can now graph a system of linear inequalities. Now, we've specifically been doing linear inequalities. What we might throw in, just so that you get the idea of, is what it would look like if we did something that's quadratic or something. Technically, that's not supposed to happen yet in our book, but it's not a bad idea to get the gist. The short answer is it's still shading above or below. So if you had a parabola, greater than would mean shade above, less than would mean shade below, equal to would mean solid line, or solid curve rather, and not equal to would mean dotted curve. So anyway, just like with the system of inequations, in order to be a solution to the system of inequalities, any solution has to be a solution to all inequalities in the system. So it has to make them true. When we graph, because that's how we usually graph the solution of an inequality, right, of a linear inequality, or when we get to it, quadratics or whatever, the solution region with single inequalities is just shaded, but the solution region for a system of inequalities is the area where all of the shading overlaps. What you'll notice if you look here on the left, right, so if you look over here, the traditional method of graphing this, and I've used a picture that I got from the interwebs, but a traditional method of graphing this is to graph the blue inequality, right, which is this dotted line, right, and then shade above, so you can see that shaded in blue, and then graph this red inequality, which is this solid red line, and then this says less than, so shade below. And what you'll notice is that your solution area then ends up being this spot down here where all of the shading overlaps, right? And that's fine, right? So the issue is that that's the way that pretty much every textbook tells you to do it, and most teachers tell you to do it. Well, most teachers will show you that out of a textbook, but then because most teachers are used to working on a chalkboard or a whiteboard, or by hand with a pencil using only one color, we'll tell you that it's really tedious if you have multiple inequalities to have to just shade and shade and shade and then kind of guess which is the darkest section where everything overlaps. It's not a great plan. So the way that I do it instead, and the way I'm going to advocate you do it, but again, I don't care, it's up to you, is I'm going to go ahead and graph these, but instead of shading, right, after I graph instead of shading, so I'm going to go ahead and graph, here's the 5 y-intercept and then the slope of -3, right, slope of -3, here's my dotted line. Okay, so I'm going to draw this dotted line, and again, of course, the one from the interwebs is much better than my graph, but that's fine, right? So there's my dotted line, and I know I'm supposed to shade above, so I'm like, oh, above would be this way. So I'm going to write some big, fat no's down here. No, 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 no. So when I graph, you're going to see a ton of no's. Okay, so I'm not supposed to shade over there, right? So after I draw the line, I write no where I'm not supposed to shade. So I was supposed to shade above, so I write no's below. Or I just make a mental note that that's not the area to shade, but I'm making the point that whether you choose a mental note or you actually write no, it doesn't matter. So then I'm going to draw the next one, which has a y-intercept of -2 and a slope of up 1, right 1. So that's going to look like this. Now it's a solid line, so I'll do my best to make a solid line that's not awful. Okay, so there's my solid line. And I notice that this one says shade below. Well, that means I'm supposed to shade this way, which means anywhere up here, these are all no's, no. Anywhere above the red line is a big fat no. Okay, so what ends up happening is that my solution area is the only area left after I've graphed all of the inequalities that doesn't have a no, and you'll notice that that's the same area that they had, and then I go ahead and shade it, right? So then I shade that, and that's my solution. You'll notice it's the same region. The graph looks slightly different because my scale is slightly different, but that's the idea. Again, I don't care which way you do it. I just want to throw out there that the idea of shading and shading and shading and shading and then looking to see which is the darkest section sounds fine in theory, but is incredibly tedious if you're doing it on a whiteboard or on a piece of homework paper with only a single color. And it's also just, you know, as a teacher who goes through whiteboard markers really fast, it's a huge waste of whiteboard marker to just shade and shade and shade and shade. So there you have it. Cool. So let's go ahead and walk through E1. So I'm actually going to treat both of these inequalities kind of as a unit, because what I want to point out is together what x is greater than or equal to 0 and y is greater than or equal to 0 says is quadrant 1, right? So I could kind of be lazy. I mean, I am technically graphing both of them, right? So x is greater than 0 is here, right? And I'm supposed to shade bigger values than that, so that would be shaded this way. So that's basically a big no in these two quadrants, right? And then y is greater than or equal to 0 is this line, and I'm supposed to shade up, right? which means that these two quadrants get big fat no's. So I know none of my shading is going to be in those two quadrants. If you can just do this by visual observation and be like, yo, that says quadrant 1, that is not cheating. That's great. I'm going to go ahead and do this one in blue. So this is going to start at 5, right? Y-intercept of 5. And then a slope of -2, so down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. I notice that this is going to be dotted because it doesn't have an equal to, and that I'm supposed to shade above, right? Dotted and above. So I'm going to go ahead and make my dotted line, which is predictably sort of bad because I'm terrible at drawing. Okay, and I know that I'm supposed to shade above, so I'm shading above, which means that anywhere below is a big fat no. No, 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 lots of no's. Okay, cool. So no in here too, in case that was unclear. All right. Then when I graph this guy, I'll go ahead and use green for this guy, right? I see that this one is solid and below because it's got an equal to and it says y is less than. So when I start at a y-intercept of 1 and I have a slope of 3, which is up 3, right 1, up 3, right 1, or down 3, left 1, down 3, left 1, it's a solid line. So I'm going to do my best to draw a solid line that's not completely and totally terrible. Okay, and I notice that I'm supposed to shade below, which would be this way, right? Which means that anything above it is a no. Well, the only spot that you might be questioning right here is this little spot here, but you can tell that this is still a no because that's also above the green line, right? So kind of look, and it looks to me like the only spot that is a reasonable answer is this section here that's in quadrant 1, right? So essentially here. Now this is, for the record, what we would call an unbounded region. So it's an unbounded region because it goes forever in some directions. Not every direction, right? But what a bounded region would look like is if the answer had happened to be like this little quadrilateral right here in the corner, right? Or this little triangle right here. Those are bounded regions. So this region is bounded on some sides, but it is an unbounded region, meaning it does go on forever and ever and ever, okay? For the record, this was also an unbounded region, right? It went forever in these directions if we go back. Okay, cool. So here's a P1 for you to try. You can pause me if you want to do it without me. That's just fine. And yeah, so I'm going to go ahead and walk through it first. And again, pause me if you don't want me to. So together, again, these guys say Q1, and you're going to see that pretty frequently. So honestly, if you know that, you could even just kind of cheat and say, you know, I'm just gonna be like, hey, these are included, and this is a big bunch of no, right? You know it's in quadrant 1. You know it shouldn't be anything outside of quadrant 1. If you want to draw the full line, that's certainly not wrong. But again, that's code for quadrant 1, right? I'll do this guy in green, right? So he is dotted, right? Because it says less than, but without the equal to, and below because of the less than. So I'm going to start at 2, and my slope is -1. So down 1, right 1, down 1, right 1. Going to make my dotted line. Okay, and again, however, you know, your dotted line can have dashes. It could just honestly be those dots because they were pretty close together. And I want to shade below, right? It says less than. So the first thing to notice is that means that this whole area up here is big fat no, right? I'm supposed to be shading below, right? I'm shading this way. So already the only feasible part that I can look at, the only possible answer is going to fall in this tiny little triangle, right? And then the last part is going to be this -2x plus 3, right? This is going to be a solid line, and I'm shading above, right? Because the greater than is above, and the solid line is because the equal to. So this is starting at 3, right? I'm going down to right 1, so that's actually going to intersect right here, right? And then down to right 1 again, down to right 1. I don't really have to go all the way to the edges of the paper because, to be honest, the part of this line that I care about is the part that falls through that triangle anyway, right? So I know that I'm supposed to shade above this thing, which means anything below the blue line is a no, right? And I only wrote the no's there. I mean, I could have written the no's all the way over here too, because this was the only area that was possibly in contention. And notice this little area here is still a no because it's under the blue line. So it turns out that after all that work, this little spot is my answer. That tiny little yellow spot is my answer, right? Which means there's not a lot of solution spot here, right? This is a tiny, tiny little window. And that's going to happen sometimes, right? So sometimes you get a tiny, tiny little spot. Now, if the spot's that tiny, you might want to double check, hey, did I do everything right? I am in quadrant 1, right? So check and check. I am below the green line, check, right? And it is above the blue line, check, right? It's not a bad idea to check all of them, even if it's a big spot, right? Even if we went back to the last example, if I were to check all of these, I am in quadrant 1 only, right? I am above the blue line. Here's the blue line. All of that is above the blue line. And I am below the green line. Here's the green line. All of that is below the green line. Check. That's my answer, right? Okay, cool. Let's walk through an example 2. So in example 2, I don't specifically have one quadrant that I'm looking at. Now I'm going to graph the easiest thing first, okay? I'm going to graph this vertical line. I noted it is vertical, right? It is a dotted line, and it would be below, but remember when we're talking vertical lines, that means the left, right? So left correct, not left right. So here's the line where x equals 1. Now I should have drawn a dotted line, and I didn't, right? So let's say that you have a pencil. Well, sure, then you just go back through and erase and make, oh, that's a very large eraser. My bad, hold on. Okay, you'd go back and make it dotted. But what if you don't have a pencil? Well, if you don't have a pencil, just make it obnoxiously dotted like this, and then put a little note that says, oops, it's dotted. Or, hey, Hogan, dotted. Or just an arrow that says dot. Like, so if you have an eraser, you could go back and fix it, right? If you don't, just make an obnoxiously dotted line, because I personally am not a math and pencil person. I don't like the way pencils sound. They make weird scratchy noises. So I've always been a math and pen person, which means if I made that mistake, it would be really frustrating because I drew a solid line when I meant a dotted line. You can just say, oops, it's supposed to be dotted, and then kind of draw some obnoxious dots. All right, so let's graph this guy. This guy is going to be solid because of the equal to, and above because it says greater than, right? So I'm going to start at a y-intercept of -1, and my slope is a -1, which means down 1, right 1. So it's going to look like this. Okay, and it's solid. And believe me, you're going to draw a solid line more than once when you don't mean to. I say this as someone who's done an awful lot of problems, and you've been drawing solid lines your entire math career, so at least once you're going to draw a solid line when you don't mean to. So just don't panic. It's not a big deal, I promise. All right, so solid line, and I'm supposed to shade above, which is this direction, right? So if you don't want to write nose, you could just put a little arrow that says, hey, I know I'm supposed to shade above, but I'm going to go ahead and write a bunch of big fat nose down here and be like, yo, I'm not shading here. Oh, I forgot to write my nose for the red. Sorry, it said x was less than 1, which meant nose here, right? Because sorry, my bad. I got distracted talking about the dotted line, and then I forgot that I'm shading this way. So right now, my feasible area to shade, like the part that I can even consider, is right here. Something else is going to happen to it in green, though, right? So this is also going to be solid, but this one's going to be below because it says less than. So I'm going to start at y-intercept of 1, and my slope is up to right 1, up to right 1. And honestly, I only care about the section of this that falls in that little region, right? So I don't care too much everywhere else. So I'm going to go ahead and draw my solid line as best as I can. Again, if the dots are there on your paper and it's clear that you're terrible at connecting dots, I'm not going to be too hard on you. So I'm supposed to shade below, which means this way, which means all of this stuff is a big fat no. And so the area that meets all of these qualities seems to be this bounded area in here. And this is a bounded area, just like I didn't mention that in the last one, but we did have a bounded area here, right? This area is called bounded because on all sides it has an edge, right? So it's bounded, it has an edge on all sides. This would also be a bounded area. All right, so there's my area. And again, it's not a bad idea to just quickly double check that they make sense. Here's my x is 1. Sure enough, this is to the left of x is 1. Here's my blue line, right? It should be above my blue line. Here's my blue line, it's above. Here's my green line, it should be below that, and it is. Now, when I do this on paper or on a board, I frequently would number these 1, 2, and 3, and then when I put them on my graph, I would label them 1, 2, and 3, so that in my brain I can say, oh, it's supposed to be under 2, because here I can say under green because I'm using a program that has multiple colors. But if you were doing this in like a pencil, it might be easier to number which one of these is which. So I just number them in order, and then I put a number next to the line so I know, hey, which one was my line 2 and which one was my line 3 without having to spend too much time on it. All right, let's do a P2. Same argument. Go ahead and pause me if you want to do it by yourself. I'm going to do the easy one first. So this is going to be a solid line, and I'm going to shade below. It is a horizontal line where y is always 3. So this is the line where y is always 3. Right, and I want to shade below it. Again, you can either just put arrows to be like to note to yourself, oh, hey, I'm shading down, or you can write those big fat no's up top, right? If I were doing this on like a project where the end result was supposed to be a pretty graph, I would go back and erase the no's, right? I would write them lightly if I were using a pencil, which again I hate, but I would do it if I had to, and then I'd erase them. All right, so then in green, this guy's going to be a dotted line, and we're going to shade above, right? So dotted and above. So here's the y-intercept of -2, and the slope is a -1. So down one, right one, down one, right one, all day. All right, and it is dotted, so I'm just going to kind of make my dots a little bit more pronounced. But again, that's up to you. Like I would just take those individual dots as a, all right, there we go. Cool. So I'm supposed to shade above, which means go this way, right? So I'm gonna put big fat nose down here. So nothing should be below the green line. Okay. In blue, this is dotted, and we're gonna go above, right? So this is at that spot 3, right? And my slope is a +1, so it's gonna look like this. And again, I noticed that there's not a whole lot of point in paying a ton of attention to what happens to this graph outside of that region where I'm possibly able to shade. So in the no region, I'm not really that worried. And I'm supposed to shade above this, which would mean going this way. So that means that everything down here is a bunch of no's. Everything below the blue line is no. And what I realize is that this bounded region, this little triangle right here that includes the red line, but I kind of accidentally shaded over it, that's my answer. And again, that is a bounded region. It has a boundary on all sides, right? That's bounded. Cool. All right. So what we're going to do in E3 is kind of the opposite of what we did in the other examples. So now I'm actually going to give you a system, and we're going to write equations for it. So even though the axes aren't written in red, you can see that the graph clearly ends. There's no shading above or below the axes. So those are also going to be, this is also an edge that we're going to have to discuss, right? This one and this one, even though they weren't written in red, they're definitely things I'm going to have to worry about. So here's what I do, and you don't have to do this, but this is what I do. I number the edges. I say, okay, here's 1, 2, here's a third side, and then this is the fourth side. That means I'm going to have 4 inequalities. So by numbering them, it makes it easy to make sure you don't miss one, right? So this is my system of inequalities. I'm just going to put a low. So number 1 and number 2 both just say in quadrant 1. Number 1 says x is greater than or equal to 0. And number 2 says y is greater than or equal to 0. Remember that these guys together are secret code for quadrant 1, right? 3 and 4 are going to be a little bit trickier. 3 is going to be the hardest. The reason that 3 is the most difficult is that I can't see the slope and the y-intercept. So let's do 4 first, okay? So 4 is easier because by visual inspection, I can see, and remember, visual inspection is just a fancy way to say eyeballs, right? That's eyeballs. I can see, sorry, that's a because, by visual inspection. I can see M and B, right? I can see that the slope of this thing is up 1, right 3. So the slope is definitely 1/3. And I can see that the line I called line 4 has a y-intercept of 4. So this is going to be y. Now notice that this is a solid line and it's shaded below, right? So I notice it's solid and below, which is less than, and also equal to, and it's going to be a 1/3 x plus 4, okay? Now, for 4, I did that in the wrong spot. Sorry, guys. Hang on. Come on, brain. I even just said it was 4, and then I wrote it in 3. It wouldn't matter, except that I'm trying to make a point to you that it keeps you more organized if you label stuff. All right. So it's not like it would matter if I listed them in a different order. I just pre-numbered them, and so I'm trying to stick with my own numbering. So for 3, I noticed that 3 is also solid and below, right? Just like 4 was, right? So 3 is also going to be y is less than or equal to. What makes 3 harder is that I can't see the y-intercept, okay? So 3, there is no visible y-intercept. Now, there are 2 ways to do this. One way is to work your way back, follow the slope, and work your way back until you figure out the y-intercept. I'm not going to advocate for that. The reason I'm not isn't because it's wrong, but because it's not the best option if you're trying to keep things simple. The best option is that you can see the slope and you have a given point, right? So you can see the slope. You can either count the slope, right? You could count down 1, 2, 3, 4, 5 and write 1, 2, 3. So you could either count the slope as rise over run and get that it's negative 5/3, or you could actually find the slope by using the point, right? You could do y minus the y value over x minus the x value, right? Because they give you both of those points, and sure enough, you'd get negative 5. So sure enough, you get negative 5/3. My bad, I got cut off, and so we're starting this video again. So then what I'd suggest, honestly, if I were you, is I would use point slope. You don't have to write the simplified version of this answer, right? So if I were you, what I would do is say, hey, I can pick either point. I can pick either the 3, 5 or the 6, 0. It really doesn't matter which. And so I could do y minus the y value, so y minus the 5 equals the negative 5/3 times the x minus the 3, right? And if I add the 5 over, I get negative 5/3 x minus 3 plus a 5. Or again, if you had picked the other point, it would look exactly like this, but it would be x minus a 6 plus a 0, right? Now, you could clean these up, but I don't see a huge reason to do that, right? Your job is just to write the inequality, and that's correct. So what's the advantage in cleaning this up? So this is probably what my answer would look like. If you chose to clean either of these up, right, if you chose to clean either of them up when you distribute, you're going to end up getting a negative 5/3 x plus 10, which is also right. If you'd written this as a negative 5/3 x plus 10, also right. So again, what we're doing here is we're putting the skill to write a system, or to write the inequality from the graph, and then we're doing it with a whole system of them where we have a whole bunch of them and we have to be able to write them. All right, so let's do a P3, okay? We're going to write the system of inequalities that's graphed it, right? And again, even though this one's not expressly listed, it's clearly there because there's no shading on the other side of the y-axis, okay? So include that one in there. So I'm going to go ahead and number them, right? I'm going to call this 1 and 2 and 3 and 4, okay? And notice again, these are all solid, right? So it's actually not a terrible thing to be like, oh, wait a second, they're all solid, right? There's not a single dotted one. That's not terrible to notice. That means that all of these are going to have greater than or equal to. So if you want to do this without me, please feel free to pause me. 1 and 2 together should just be telling me quadrant 1, right? So that's going to be x is greater than or equal to 0 and y is greater than or equal to 0, right? 3 is going to be the tricky one, right? Because 3 is going to be the one where you can't see the y-intercept. And 4 is going to be the one where you can see m and b, right? That says and b. So in 4, you can see m and b, right? So I already did 1, I already did 2, right? Let's go ahead and jump to 4. For 4, I can actually count the slope here, right? The slope seems to be up 1, right 2. Oh, that's not right. It just looks like it, but it's not, because if you hit that point, it's actually up 2, right 5. My bad. So the slope, tricky. The slope in 4 is up to right 5, right? And the y-intercept in 4 seems to be at 2. So for 4, notice that we're shading, so 4 was solid. We knew they'd all be solid, right? And below. So 4 is solid and below, which means y is less than or equal to 2/5 x plus 2, right? If we do the same thing for 3, now with 3, right, so 3 is solid. It's below because remember, if you put a guy on this ladder, like if you had a guy stand on the ladder and a guy hang under the ladder, the shading is clearly the guy hanging under the ladder, right? So it's solid and below, so I can go ahead and put y is less than or equal to, even if I don't know what the curve is going to look like, right? I can find the slope of this thing by counting, right? It's down 4, right 1, so my slope is negative 4 over 1, which would be a negative 4, right? And then you could use either point, so I'd get y minus the y value equals m, which is negative 4 x minus 5, which would be the same as y equals negative 4 x minus 5 plus a 4. Or if you picked the other point, it would have been negative 4 x minus a 6 plus a 0. Or if you stubbornly decided to clean this up entirely, it would have been a negative 4x plus 24. Any of those would be fine. So whichever one you pick, I'll be honest, I probably would have picked this one, x minus 5 plus 4, but any of them are fine. So any of these would have been fine, right? I just picked that one because that's probably what I'd pick, and that's my inequality. So that's the end of our video for 3.4. We only have the one video because, again, we've done most of these skills in previous videos. 3.4 also lists, just to make a note, so 3.4 is actually the one, if you look in the book, that has examples like this, right? and something like -1 is less than or equal to y is less than 3, right? But we actually did that the other day, right? So we did that in 3.3 because that's kind of naturally where it came up when we were learning to graph the horizontal and vertical lines. But if you were trying to do that, right, remember essentially what it looks like, right, is, so if we called this 2, 3, 4, 5, right, this would be an open circle at 2 and a closed circle at 5, right? And so essentially what this ends up looking like is as though you had, what it ends up looking like is that you, oh, hey, it didn't make it solid. That's very frustrating of it. Well, you get the idea. So that's supposed to be solid, but if you drag this thing down, you end up getting something that looks like a solid line here, a dotted line here, and the middle is shaded, right? And that would be what it would look like if we had a y-axis, right? So if I had a y-axis right here, that would be what this would look like, right? It would go up forever, okay? And so we saw that in the last example, right? And the same thing here, if I had, right, so if I treated this just as a one-dimensional number line, right, in a one-dimensional number line, this would look like an open circle at -1 and a solid dot up at 3, right? And if I were to take this thing, oh, it hates me. There we go. There we go. So if I were to take this thing and drag it across, what would end up happening is I'd end up with a dotted line here, a solid line here, and shading in the middle, and that's what that would look like, right? So just to show you what it looks like. We did that in 3.3, so don't panic that you're not doing an example of it now. If you need to go back and revisit it when you work on the 3.4 homework, it is in the last video from 3.3. Cool, that's it for 3.4.